Everyone, welcome back. So now let's answer a really important question, like where does all this radioactive material come from in the first place? Because, if you know anything about stars, well, you realize that fusion can only go up until iron. So that's why the core of a star is usually iron. So we can see right here, little iron core. And we saw that from earlier when we had that amazing graph that showed us the energy per nucleon for elements. And there was this peak right here, which is about iron, which simply says that you can only produce energy from fusion by going up to iron. Past that, it starts taking energy. And you can only produce energy from fission by going down to iron. So in either way, we can't make more energy, so where does it come from? So let's talk about that real quick. So the long and short of it is supernovas. Okay, supernovas are where a lot of these heavy elements are created. There's two types of supernovas. One that's not really important for us. We have a red giant, accidentally goes too close to a white dwarf, and it gets eaten by the white dwarf before the white dwarf finally, boom, explodes. The second one is the important one because this is where we're going to start seeing those heavy elements really be created. So in a normal star, fusion works by turning hydrogen into helium. And that helium gets turned into carbon, going all the way up the chain until it finally turns into core. There's an issue though. Eventually, a giant star, a very, very big star, well, it's going to start running out of hydrogen. But you're like, okay, why does it matter? It just stops burning. But the issue is this. The only reason that star hasn't collapsed before this point is because there is a humongous amount of pressure being sent out by the energy from fusion. So the heat energy from fusion and all the other radiation it sends out is actually pushing back on the gravitational pressure from the star. So rather than collapsing down, it stays at a constant size, or roughly constant. Eventually, it can't do that anymore. Eventually, it's unable to resist the pressure of its own gravity pulling it inward. And so when that happens, you have a whole bunch of heavy elements, as well as hydrogen, that finally can fall in, and they smack into the iron core with a humongous amount of force. This then causes a rebound, which leads to finally a giant explosion. Now, the big thing I want you to get here is that I have a big element. I'm not going to try to draw all of them right now. And I suddenly have a bunch of other elements which are running at it at incredible speed and high temperatures. This is a wonderful and amazing moment where we can have fusion. So this leads to me having iron plus something else, which leads to all those heavier elements like uranium, plutonium, and everything else that we see that's radioactive and is much bigger than iron. So this is where it comes from. Any of those bigger elements, they're coming because a star at some point exploded and we're seeing its remnants today. Okay, where else can we see these radioactive elements come from? Well, particle accelerators, for one. So particle accelerators take a charged particle, we can say like a proton here, and using a potential, it can accelerate to massive velocities before it smacks into something. Now when it does that, it will a lot of times create a radioactive element. It will also cause that thing to just explode and amazing physics will be done. But for us, we're mostly caring about nuclear reactors. So nuclear reactors, we're sending neutrons at something. It will make it less stable by hitting it. And when it makes it less stable, it will then want to decay. And that decay means it's radioactive. So this is where all this radioactive material comes from. Initially, stars exploding. For us, though, what we really care about is the stuff that's in nuclear reactors. And so it's just neutrons smacking into things, making them less stable. And so they have to decay to something that is more stable. Thanks for listening. I'll see you all next time. Bye-bye.